Hi, this is the video for Chapter 3, Lesson 2, titled Rational Numbers. So you can get your study guide out in front of you and also your notebook because we're going to take some notes. So the first thing we're going to take a look at today is just classifying numbers. In our last chapter, we took a look at working with whole numbers, and we also took a look at integers, and so that was a newer concept for us. Okay, so if you were to describe what a whole number is, how would you describe it? If you're around someone, you can pause this and talk to them for a second of how you would describe whole numbers, and I'd also like for you to describe integers. So as you're going with this, I'd like for you to also draw this chart in your notebook, because we're going to also be able to kind of break down what these numbers are. So whole numbers would be kind of like your counting numbers, if you can pull up fingers and count. And these would be numbers that you would be taught from a young age, right? 1, 2, 3, 4, right? Some other whole numbers could be like 29 or 35 or 102, right? Any whole number. So it's not a decimal, it's not a fraction. And 0 is in there, is counted as one of the whole numbers. So integers, if you remember from last chapter, it's basically any whole number and its negatives, right? So any of these numbers we wrote down here, but we can include those negatives, right? So +1, -1, or -4, +4, or +102 or 102, right? -29, 29. So any of these integers, so we could say -5, 7, 8, I don't know, -15, right? So any number that can be written as a negative, any whole number that can be written as a negative is counted as an integer. So the last category we're going to look at is called rational numbers. Have you heard this term before? Rational numbers. So the simple way of describing what a rational number is would just be any number that can be written as a fraction. Okay, so if you want to write that down as part of the definition, you can put that in there. So a rational number is really just any number that can be written as a fraction. And so we've got our final little category here. So let's think of some numbers that can be written as fractions. Well, any number that's a fraction, right? So I could say 5/7, or I don't know, 2/5, or 1/3, right? Any of these would be rational numbers. But how about 0.25? Can this number be written as a fraction? Yeah, right? This would be 1/4. So any decimal that can be written as a fraction would be included in that. If I had 0.6 repeating, that's actually 2/3. And so if I have a decimal that can be written as a fraction, that would be counted as a rational number. So would the number 5 be counted as a rational number? It would, because I could write it as 5/1, or I could write it as 10/2, right? And these are all examples of fractions. So whole numbers and integers are also in the category of what a rational number is. So if, as you've been graphing and putting this chart down, you see that whole numbers are included in what an integer is, and integers are included in what a rational number is. That's why I have the smaller category and then the bigger one and the bigger one, and they're all within each other, right? And so any number that can be written as a fraction would be a rational number. Now, there are times when you see decimals that can't be written as a fraction. So a decimal that maybe has no pattern, right? This decimal has no pattern and it keeps on going forever. This would not be a rational number. Now, this is called an irrational number. So you can think of the irrational number as basically the opposite of a rational number. It's any number that cannot be written as a fraction. You can't turn it as a fraction. That would be irrational. Another example would be like pi. Pi is irrational. These are like decimal numbers, and I'll put a definition here for us. Decimal numbers that are infinite and non-repeating. So when you see numbers that are not infinite and they repeat, chances are that decimal can be written as a fraction. So what we're going to do next is we're going to classify some numbers and decide what kind of category they fit into. Okay, so let's do a few here together, and you can just verbally respond if you'd like to. I'm going to just put up a few here. -12. What would this be? If you said integers, you're correct. And so this is an integer, but we're going to describe it as any classified number that it can belong to. So what else could this be? This could also be a rational number. So we would want to say that it's both. It's an integer and it's a rational number. Okay, how about this number here? 582. If you said that this is a whole number, you're correct. But we also want to describe it as basically any category that it can also fit into. So this would be counted as also an integer, and it would be a rational number. So if you see that a number is a whole number, any whole number is an integer and a rational number. So we would say it's a whole number, it's an integer, and it's a rational number. So you can write W, I, and R for these terms here, and then just spell out irrational. Write that out as a whole word when you see that. So let's take a look at your study guide, because you've got a bunch of examples on your study guide, and we're actually doing the back of your study guide first. And so let's flip to the back side, where it talks about the little graph here. It says classifying rational numbers. And if you look at your study guide, you also have this little graph that's shown you just a visual of what these numbers represent. So you can take a look at that, but sometimes it helps our brain process what we're learning as we write it down. So down here on the exercises, we actually did number 1 and number 3. So you guys can fill in the answer from what we did earlier. -12 is a, use a different color here. -12 is an integer and a rational number. So you could write I and R here. And then 582 is a whole number, an integer, and a rational number, right? An example of an irrational number might be number 8 here. It keeps going forever and it's non-repeating. So we would spell out irrational here for this one, irrational number. Okay, I'd like for you to pause this and work all of these out. Okay, it shouldn't take you too long, but think through, especially if it's decimal. If it's a repeating decimal, it probably can be written as a fraction, and we'll take a look at that next. So if it's a repeating decimal and it goes on forever and ever, it is a rational number. It can be written as a fraction. So that's just a little hint for you as you do these problems. So pause the video, work it out, and when you press play, I think I should have worked this out already. So, okay, here we go. Let's check our answers. So if you want to pause the video and just check these answers as well, you're more than welcome to. We are going to now look at the other side of our study guide, which is really technically the front side, but I thought it'd be easier to do that side first. So what we're gonna take a look now is making sure we can turn our rational numbers into fractions. And so there are times when you see one that's already a fraction, but for this practice, we're just going to turn all our fractions into improper fractions, which means your number, there's no mixed numbers. So your fraction is basically just a numerator and a denominator and no whole number on the side. So for all our answers, when we get to the bottom here and we do turn our numbers into fractions, we can write all our answers as improper fractions. So it means just you have a numerator and a denominator and that's it. So if we see a mixed number, we want to turn this into an improper fraction. How do we do that? So we can think we've got 3 wholes and 2/5, right? So if we turn our 3 wholes into pieces, into the parts, then there would be 15, right? And we can do that by multiplying 3 times 5. But we've got to add these two parts as the numerator into what our other parts that we found was. So that would be 15 plus the numerator, and that would be 17, right? So our answer is 17 over 5. So your improper fraction for this is 17 over 5. If we see an integer and we want to turn this into a fraction, well, it's a whole number, kind of, right? It's a whole number that's a negative. So we would just write this as a negative 7 over 1, and that's it. Okay, if we have a decimal, we're going to count out the amount of places that our decimal takes up. So because this is 14 hundredths and the last number that we see is in the hundredths place, we're going to put it over 100. So it can be 14 over 100. And then we're going to simplify. So even though your answer is going to be an improper fraction, still make it as simplified as possible. So we're going to simplify this. We can divide everything by 2, and the answer is 7 over 50. Okay, the last one is looking at repeating decimals. We're not going to focus on that right now because the process in doing this takes some algebraic equation skills that we haven't even learned yet. And so we're actually going to just not worry about this, okay? You won't be tested over it and you don't have to do it. We might go back over it in the future and look at how to do it once we've done a little more algebra, but for right now, I think that's a little too advanced for us. So what we're going to do here is just turn these numbers into fractions. And if you see a decimal that's a repeating decimal, just cross it off and don't do it. And on your homework, if you're assigned any problems that are repeating decimals, just cross that off and don't do it. Just know in your head that repeating decimals can be turned into a fraction, okay? But we won't worry about actually doing that. So let's do these first 3 together, and then I'll let you loose and you can do the rest of them. So number 1, to write this as an improper fraction, we do 1 times 5 and then plus 1, right? So that would be 6 over 5. There's one whole piece and then another partial, one like piece out of 5, right? And then right here we've got -2. So we write this as just -2 over 1 as our fraction. And then number 3 is I've got 7 in the 10th place. So it's 7 over 10. I'm going to put it over 10 because it's in the 10th place. And I can't simplify this. So that's my answer, 7/10. All right, you guys go ahead and work out those problems, pause the video, and then you can play it and watch the rest in a second. Okay, so I don't know if you're stuck on a few, but I wanted to take a look at these with you. Number 4 and no, not number 4, number 7, and number 10. We're going to take a look at those together. I did them partially, but I'm not completely done with them. And so I want to talk about number 4 with you. So here, if you put 32 over 100, you're not all the way done. You need to simplify this all the way. So hopefully what you put was 4 out of 25 as your final answer. Okay. Number 7. Now, this is still a mixed number, 5 and 28 over 100. This is one way to start off. You could also have started off by writing 528 over 100 and then simplified it. But when we look at this, we realize that we need to simplify our fraction, whether it's 5 and 28 over 100 or 528 over 100, okay? So if we were to write it as a mixed number first and then simplify, we would have to simplify 28 over 100 and make this, what would this be? Divide by 4 maybe, so that would be 7, and then this would be 25. Okay, so 7 over 25, I believe. I'm going to bring this down here. So 5 and 7 over 25. But then when we work this out, we have to do 5 times 25 and then add on our 7. And that would be 132 out of 25. And same thing here. If we were to simplify all this, we could simplify everything by 100. Or no, not 100, by a number that is divisible by these two. And when we simplify it all the way, it becomes 132 over 25. And we're going to leave that as our answer because we're going to keep it as an improper fraction. So let's take a look at number 10. Now don't forget this little negative on the side. But out here, you could have written it as 9 and 8 over 100, or you could have written it as 908 over 100. Okay, and then that's negative, okay? And so when you simplify this all the way, it actually becomes negative 227 over 25. So that is your final answer. But don't forget to simplify it, okay? Here, the answer, number 8, the answer is negative 47 over 6. And then number 12, the answer is 74 over 11. I can't simplify that. So those are your answers. You guys, if you're all the way done with this and you have time left, you guys can work on your homework. And so your teacher will give you what your homework is. Good job today.